Hello students and welcome to the lecture. So students, as you can see here that basically in this lecture we are going to start the discussion over the light. Okay, this is going to be a topic for the discussion and this is going to be our part 1. Okay, so we will cover several lectures in several parts over light and this is the part 1. In this lecture what we are going to see, we will talk about light, what is exactly meaning of light, review of light, rectilinear propagation of light, shadow, eclipses, pinhole camera. These three things, these 6 things: light, review of light, rectilinear propagation of light, shadows, eclipses, pinhole camera. Okay, so these areas are going to be the fittest square for us during this discussion. Okay, but before starting the actual lecture, as usual, we have the small disclaimer over here that we are required to understood before we proceed further. So disclaimer is like the images used in a slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. Now, let's begin the discussion over the light. So when we talk about light, what exactly comes in our mind? That is the first thing that we are required to clear off before we proceed further. So basically, in the normal terms or in the layman terms, you can say the light is just a torch, a tube light, a bulb. Okay. Even sometimes we say it as a electricity, that the light is not at home. What do you mean? The electricity is not at home, right? Generally, we perceive the light is any kind of thing through which we could luminify the room, luminify the place. Okay. That is what comes in our mind whenever we talk about light. This is true. There's nothing wrong with it. Okay. But when you are saying this in the layman terms only, then this condition is condition. But when we take it into the scientific field, in the field of physics, this thing is half true, half false, or you can say half incomplete. So what do we mean by this half incomplete? Yes, this is what we are required to understand before we go further. Okay. So if light is anything through which we could luminify the place. Okay, this is half true and half incomplete. Why? Light could luminify the place. But how? Why? What are the phenomenon associated with light? These are not included. These are not explained in the statement that light is basically illuminify the place. That's why I say this is an half incomplete sentence in the field of physics, in the field of science. In the layman terms, it is okay, but in the field of physics or science, it is half incomplete. So how we could complete it? How we could completely say that this particular definition, this particular statement defines the light in the field of science? For that, we are here to discuss this in the scientific term. So here you can see the one line that is written over here. Light is the form of energy, makes object visible to our eye. Now, suppose you are standing in a room and this room is a dark room. There is no light. Okay. So if I ask you, what are the objects placed in that room? Could you tell me? No. Why? Because the objects are not visible to your eye. You are standing in a complete darkness. Okay. You will say that I'm not able to see anything. I can't tell. That is what I'm expecting from you. If I'm making you standing in the room where there is only dark, there is no light. Then you switch on the button and suddenly the tube light that was on the terrace. Okay, that light glows up, and then there is a light in the room, and now you are saying, okay, there are the four chairs only. So now just compare these conditions. First condition, when there was a darkness. Second condition, when there is a light. In the first condition, you were unable to see the things. Why? Because there was no light. In the second condition, you say there are the four chairs only. How? Because now the chair, which are the objects, visible to your eye. Okay? So light is actually that form of energy which makes us capable to look at the object clearly or makes the object visible to our. Okay? The branch of physics which deals with the nature of light, its source, properties, effects, and vision, that is called optics. Okay? So you can say in physics, we have actually studied everything in a different branch, in a different discipline. So a branch of physics, a disciple of physics, where we specifically or specially talk about the light, its nature, source, properties, effect, and its vision, then that particular disciple or branch is what we call as an optics. Got it? That is the optics. For the sake of convenience, optics is divided into two parts, named are geometrical optics and physical optics. Okay? This division that we had made in the optics, dividing it into the geometrical optics and physical optics, that is for our convenience only. Geometrical optics first treats with the propagation of light in terms of rays and is valid only if wavelength of light is much lesser than the size of obstacle. So like in the normal geometry, what we understood, we talk about angles, we talk about lanes, okay, we talk about the lines that are making angles and all. That is what we generally talk about in the geometry. Okay, so when we are only talk about the propagation of light in the terms of rays, and if it is a ray, it means it is a straight line, and whenever it will stuck with any kind of object, it will make some angle. Okay, so here also the linear propagation and making of angles taking place. That's why we simply termed it as an geometrical optics, where the propagation of light is defined in terms of ray and valid only if the wavelength of light is much lesser than the size of obstacle. If the wavelength of light is higher than the size of obstacle, geometrical optics is that not much effective there. Okay. It concerns with the image formation and deals with the study of simple facts such as rectilinear propagation, laws of reflection and refraction by using the geometrical method. Okay. Thereafter, the physical optics. The physical optics further divided into two parts, with wave optics and quantum optics. Okay. So in geometrical optics, there is no further division, but in physical optics, yes, there is a further division. Wave optics and quantum optics. Wave optics concern with the explanation of the observed phenomena such as interference, diffraction, and polarization. In light, it is treated as a wave. Quantum optics treat light as a particle, localized energy packet called photon to deal with the photoelectric effect, Raman effect, and laser, etc. So, physical optics, as we know, further divided into wave optics and quantum optics. Wave optics is actually concerned with the explanation of observed phenomena when interference is there, diffraction is there, polarization is there. Okay. And remember, all these phenomena, interference, diffraction, and polarization, are actually related with the wave. Quantum optics, on the other hand, treat light as a particle. Quantum optics says the light is not a ray, it's actually a localized energy pockets that we call as photon, and these photons traveling in a straight line just after each other with the speed of light. That's why they appear as a wave, but they are not the wave. And that deals with the photoelectric effect, Raman effect, laser, etc. Review of light. Let's have a look on this. So light is actually a form of energy which is propagated as electromagnetic wave. Therefore, light does not require a medium for its propagation. Remember, the electromagnetic waves generally not required any medium. What is the medium? Solid, liquid, gas. This is the medium. Okay. So light not required solid, liquid, or gas to move. Okay. It could even travel in the vacuum. So first point is clear. Does not require any medium for its propagation because it is an electromagnetic wave. Its speed in free space, therefore vacuum when there is no medium, no solid, no liquid, no gas, anything is there, is 3 into 10 power 8 meter per second. It is transverse in nature and so can be polarized. It is not deflected by electric and magnetic fields. In it, electric vector E, magnetic vector B, and direction of wave motion are always orthogonal and E and B are in the same phase. In the spectrum of electromagnetic waves, it lies between ultraviolet and infrared regions and having a wavelength between 4000 angstrom to 7000 angstrom. Therefore, 0.4 to 0.7. The speed of light in free space equals to 3 into 10 power 8 meter per second is independent of relative motion between source and observer. Therefore, whatever the motion of the source of light and whatever the motion of the observer who is observing the light, that is not having any effect on the speed of light in the free space. Therefore, C plus minus V equals to C. So, historically, it was first determined by whom? Roemer in the year of 1676. Through eclipse of none of the moons of Jupiter, the first laboratory measurement of velocity of light was carried out by Fizeau in year 1849 using a rotating two-third wheel. Optical frequencies are of the order of 10 power 15 Hz. When light passes from one medium to another, velocity and wavelength may change. Amplitude may decrease or remain constant, but frequency and color of light do not change. This is an important. Suppose light is moving from one medium to another. Here you can see air, gaseous medium, water, liquid medium. Okay. So here the light is coming from here and then going here. So what is happening actually? The medium is getting changed. Previously the light was traveling in air and suddenly it got enter into the medium of liquid. Okay. So the velocity of light, and the wavelength of the light, that may get changed. Okay. Maybe the light have a more speed in air than the water. Maybe the wavelength is high in air than the water. Amplitude may decrease or remain constant. But the frequency and the color of light, that do not change. So these two things remains constant whether light is moving in one medium, another medium, or any other medium. That will not change, that remains as it is. Therefore, the color of light is determined by its frequency and not wavelength. Because frequency is constant throughout the medium. That is not going to change, but wavelength may change. So if you go determining the color of light by the wavelength, then what could happen? The wavelength in one medium is different than the another medium. So you have to change the color also. right? But if you determine the color of light by using the frequency, which is constant in every medium, then what will happen? Whether the light is in air, whether the light is in water, even it touches any solid medium, that will not change because the frequency and color of light remains constant. So that's why it is a good idea to measure the color of light, determining the color of light by using the frequency, not using the wavelength. Examples are there. If red light passes from air to water or glass, velocity and wavelength in water or glass will be different from that in air, but frequency and color remains the same. Because we know when light passes from one medium to another, velocity and wavelength match. So here you can say air is gaseous, water is liquid, glass is solid. Okay. So if the light is changing medium here, so when it go from air to water, water to glass, its frequency and color remains constant, but its velocity and wavelength is changing. Okay. Velocity of light for all wavelengths in free space is same and equal to 3 into 10 power 8 meters second. That is not going to change for every wavelength in a free space, or you can say vacuum. However, in a medium, the speed of light is different for different wavelengths in accordance with the relation. So remember, when the light is traveling in the vacuum, the velocity of light for any wavelength remains the same. Okay, because free space or vacuum there is no medium. But in the case of medium, the velocity is differs for the differs wavelength. The speed of light differs for the differ wavelength. Like you can say V is directly proportional to lambda. Therefore, in a given medium, greater the wavelength, greater will be the velocity of light. Okay. So remember, if for example there is a solid glass and there is a liquid water. So if the wavelength of light is greater in water than the glass, then the velocity of light will be higher in water than the glass. Similarly, if the wavelength of light in air is greater than the wavelength of light in water, so the speed of light in air will be higher than the water. Okay. Example, as lambda red is greater than lambda violet in water or glass, so that's why the velocity of red is higher than the velocity of violet. The speed of light in a medium is lesser than the velocity of light in vacuum. Why? Because in vacuum, in the free space, the light having the maximum velocity. In medium, actually the velocity and wavelength changing amplitude is may decreasing or remaining constant. So that's why the speed of light becomes less in comparison with the velocity of light in vacuum. If the same light passes through the different media, then denser the medium, lesser will be the speed of a given light. That is what I'm trying to say. So, suppose light is coming from vacuum, entering into air, then water, then glass. Okay. So here you can say when it is coming from vacuum, it's having the highest velocity on that time. Then when it's entering into air, the velocity is becoming lesser. Then when it enters into the water, more the velocity will become lesser. When it enters into glass, the velocity will be at the lowest in comparison with all these four stages: vacuum, air, water, and glass. And why it is happening? Because of this particular statement. Denser the medium, lesser will be the speed. Vacuum is less denser or it's not denser at all. That's why the velocity is maximum. Air, little bit denser than vacuum, thus velocity becoming lower. Water is more denser than the air, velocity becoming more lesser. Glass is the highest denser medium in comparison with water, in comparison with air, in comparison with vacuum. That's why the velocity or speed is the lowest. Okay. Example, in case of propagation of light from air to water and then to glass, the same example that we have taken. So the velocity in air is greatest or more than the velocity of water, and velocity in water is more than the velocity in glass. The velocity of light in a medium such as water or glass is same in all directions. The medium is called isotropic. However, if the velocity of light is different in different directions, example in cell sites or quartz, etc., the medium is said to be an isotropic for that light. Light of single wavelength is called monochromatic. Therefore, monochromatic light consists of a large number of waves of same wavelength. So when the light of single wavelength comparing the large numbers of wavelength of same large number of waves of same wavelength consisting in one light appearing as a single wavelength, then it is a monochromatic. Got it? Sodium light is nearest to monochromatic light. So this kind of yellow, you can say street bulbs you have seen in your locality. So those were the sodium light. Actually, the sodium light is bichromatic with wavelength 5890 angstrom and 5896 angstrom, while white light is heterochromatic. Laser is also monochromatic, coherent, intense, and unidirectional beam of light which has very small tendency to spread. That is a laser. Have you ever tried to play with laser? In your childhood, you will try. You have already tried. Okay, like this kind of uh, object we got, and whenever we press the button, we saw a red, green, or yellow dot on the object to which we directed it. Right? So that was laser. Laser is actually a monochromatic. Like if you are having a laser that having a green color, red color, yellow color, so you will only observe that while directed it towards any object, only that color will appear. Okay, because it's consisting only the monochromatic light. The intensity is higher and this is unidirectional. Why? Suppose just take a torch and take a laser, flash both and directed it towards the wall. You will find out that the torch is actually spreading over the wall, right? Because that is multidirectional, not unidirectional. Even some part you will see some light of torch is also reflecting on the ground. But in the case of laser, you will find out when you press and direct it towards any object, what you will observe that that light is actually the unidirectional, right? Unidirectional, that is not going to be spread. You will see it as a dot only on the wall. Okay, so that is the thing. That is a beam of light because if you are using that laser object, so this kind of beam you will observe, which having a very small tendency to spread. As I have told you, if this is a wall, you will only find it on any particular spot. You will not find it here, there, here. Only the one particular spot. Why? Because it having a very small tendency to spread. Got it? The word laser is an abbreviation actually. Light amplification by stimulated emission of radiation. Okay. In competitive exams, this becomes important. Kindly take this into the consideration. The laser is not any term. The laser is not any term. It is actually a short form, or we could say abbreviation in the standards of English. And the abbreviation stands out for light amplification by stimulated emission of radiation. So this is what actually laser means. Okay. And this kind of questions you can easily see in the examination that sometimes they ask, what is the full form of laser? And on that time is the time when we start thinking that laser is a term only, right? Laser is not having any kind of full form. And that's what we make a mistake. As here I have told you, laser is not any term. Please do not consider it any term. It is actually an abbreviation of the full form light amplification by stimulated emission of radiation. And that's why I told you this is important. Okay. So laser is always colored and can never be white as it is monochromatic. Why? Why laser is not white? Now, this is the concept that we are required to understand. Whenever we saw a laser, okay, whenever we used it in our childhood, some of you may be still using them, okay, you will find out that laser is never be a white light. It's always colored, whether green, whether red. Why? Simple reason is that green or red, these are the monochromatic light. White light is actually the group of 7 or many colors. So that's why the white light is heterochromatic light. Okay. So if the laser would be a white light that is actually consisting many colors, that is not possible, because if many colors will use, the tendency to spread will be higher. And we know the laser always having a small tendency to spread. Okay. So that's why laser is always colored and can never be a white, because it is monochromatic. So this thing become clear now. The rectilinear propagation of light, in spite of its wave nature, attributed to its small wavelength. Therefore, due to its very small wavelength, it appears to travel in a straight line. Now, as the distance between Earth and Sun is 1.5 into 10 power 8 kilometers, light takes bracket 1.5 into 10 power 11 by 3 into 10 power 8 bracket close equals to 500 s, which equals to 8.3 minutes to reach Earth from the Sun. So you can say, if this is Sun and this is Earth, the light takes total 8.3 minutes to cover this distance and fall on the Earth originated from the Sun. Light year. So light year is the term that you have often heard in the physics. Okay. So light year is not a unit of time. We generally considered it that it's a unit of time. It is not. But of distance and is equal to the distance traveled by light in 1 year in free space. Okay. So how much distance the light has traveled in 1 year in the free space or the vacuum, that is actually called as light year. Therefore, 1 light year is equals to 3 into 10 power 8 bracket close into 3.16 into 10 power 7 bracket close meter, or equals to 9.48 into 10 power 12 kilometers. After the Sun, the nearest star, Centauri or Alpha Centauri, is at a distance of about 4.3 light years from the Earth. Visibility of an object from all directions is due to the scattering of light. Okay. For example, if you place any object here on the table and you placed a torch over it, only from one direction, and you stand behind it. So might be you not see this object. Why? Because the object only spreading light like this. Only the person who's standing there could observe the light, not that one. Okay? Because this object is not scattering any light backward. It is only spreading the lights or scattering the light in the forward direction. So that's why if you can see an object from all the direction, it is due to the scattering of light. If you are seeing a table in front of you and you can see it from any corner of your room, it is because that table is scattering the light in all the directions of that room. Here, it is worth noting that in case of refraction, an object will be visible in a specific direction only. So scattering phenomena is the only phenomena that makes the light able to make the object visible from all the directions, while reflection or refraction could only make the object visible in a specific direction. All objects which are visible to us are sources of light. However, if the source emits light, it is called self-luminous, like example of sun or fluorescent tube, because they are emitting light by themselves. Otherwise, non-luminous, moon and book and table also, because these objects not emitting the light by themselves, but we are seeing them as luminified because some light is reflecting on them. In case of luminous object, if the object emitting light are not the phenomenon is called incandescent, and if cool luminous, example glowworm, TV screen, radium, dial clock, etc. In case of luminescence, if the time interval between the excitation and emission is lesser than 10⁻⁻8 seconds, as in the tube light and LED, the phenomena is called fluorescence, otherwise phosphorescence. In the case of phosphorescence, the object, such as radium dial clock, continue to glow for some times even after the source of excitation is removed. In a medium, light travels in a straight line path. This is what we're talking about, the rectilinear propagation of light. So whenever we talk about the rectilinear propagation of light, we always say in a medium, light travels in a straight line path. This is what we call as the rectilinear propagation of light. Formation of shadow and eclipses are the direct consequences of rectilinear propagation of light. Note, a careful observation reveals that light bends at the edges of object. Remember it. The phenomena is called diffraction and explained by the consideration of light as a wave. The effect is appreciable if the size of object in the path of light is very small, of the order of 10⁻⁻4 centimeter or smaller than it. Now here is a term, point of source of light. What do you mean by this? A point source of light is actually obtained by placing a screen with a pinhole camera in front of a lighted bulb, or by placing a lighted bulb inside a box having a pinhole in one of its sides. The pinhole acts as a point source of light because this is the point from where the light is coming out from that particular box. A bulb or any other source of light is an extended source of light. Ray and beam of light. The light coming from a point source spreads in all directions. The path along which light travels is shown by drawing a straight line outward from the source and called a light ray. Here you can see. This is the point light spreading in all the directions. The arrow on it represents the direction of travel of light. Here you can see them. It is impossible to obtain a single ray of light from a source because that is not a laser that stimulated from a particular place. That is a normal light case. A group of adjacent light rays obtained from a source is called a pencil of rays or beam of light sometimes. A beam of light could be emergent, convergent, and parallel. First case is emergent beam of light. A beam of light emitted from a point source is actually the emergent beam. Here you can see. Point source is spreading in all the directions, emergent beam. Convergent beam of light. A beam of light coming towards a point is convergent beam. Here the point is lights coming towards it. Convergent beam. Parallel beam of light. A beam of light from a distant source such as sun is a parallel beam. If the source is at a quite distance, the light will travels in a parallel line. Here you can see. Medium. The substance through which light passes is called a medium. The substances which pass most of the incident light through them are called transparent. Examples are water or glass, while the substance which pass partial light called translucent. Examples are tracing paper. The substance which having no tendency to pass the light at all through them, these are called the opaque, like mirror or cardboard. Here you can say transparent, light passes through. Translucent, only some light passes through. Opaque, no light passing through at all. Now the shadow. What do we mean by shadow? Let's understand it. So an opaque object placed in path of light obstructs the passage of light and produces a dark patch behind it. The dark patch called the shadow of the opaque object. So here is a point of light. There is a opaque object. Now you can say the light stuck here and went to another direction. No light reached this point. So here you can say this is the black dark shadow. The formation of shadow is direct consequence of the rectilinear propagation of light. The shall now consider two different cases. First case, shadow produced by a point source of light. Second, shadow produced by an extended source of light. For the producing of shadow by point source of light, we could say, in case of point sources, the shadow has sharply defined outline. In this case, size of shadow is always bigger than the size of the object. If the distance between the screen and the object increased, either by moving the screen away from the object or by moving the object towards the source, the size of the shadow or umbra increases. Second case is shadow produced by an extended source of light. For an extended light source, the shadow has two distinct regions, one in which no light reaches called umbra and other in which partial light reaches called penumbra. Shadow, if the source of light is smaller than object umbra, no light zone, and penumbra, partial light zone, both are formed due to the rectilinear propagation of light. However, if the object is smaller than the source of light, like figure B, umbra will be formed if the screen is close to the object, like between O and C. Here you can see. And will not be formed if the screen is distant from the object beyond the C. Like here you can see, no umbra is formed. This is why a high flying bird or aeroplane does not cast a shadow on the ground when flying high, because they having at the quiet distance, while it casts a shadow when flying close to the ground, because now they are close to the screen. Optical path, defined as distance traveled by light in vacuum in the same time in which it travels a given path length in a medium. If light travels a path length d in a medium at speed v, the time taken by it will be dv. So optical path length. L equals to c into dyb equals to this, and civ equals to this. As for all medium, optical path length is always greater than actual path length. Eclipses. The formation of eclipses is based on the principle of formation of shadow. Therefore, it is the direct consequence of rectilinear propagation of light. There are two kinds of eclipses depending on the relative position of the earth and the moon. The lunar eclipse, therefore the eclipse of the moon. The solar eclipse, therefore the eclipse of sun. For lunar eclipse, when the earth comes in between the sun and the moon, the light reaching the moon from the sun is obscured by the earth. Here you can see, this is moon, this is sun, earth is between them. So the light that was reaching the moon is getting obstructed. This marks the moon invisible to the observer on the earth. Therefore, lunar eclipse takes place because moon is non-luminous object. The lunar eclipse always occur on a full moon night, but does not take place on every full moon night because the orbits of earth and the moon do not lie in the same plane. Therefore, the sun, the earth and the moon do not lie in the same line on every full moon. The orbit of the moon is inclined at angle of 5 degrees to that of the earth. Solar eclipse is second case. When the moon comes in between the sun and the earth in the same line, a path of light reaching the earth from the sun is obstructed and the solar eclipse takes place. So here you can say, this is what the solar eclipse is. Obviously, this happened on the some new moon day. Pinhole camera. Last point to be discussed. A pinhole camera is a direct consequence of a rectilinear propagation of light. The formation of inverted image in a pinhole camera is explained by the rectilinear propagation of light. Characteristics of the image is real and inverted, may be diminished, enlarged, or of the same size. The size of image depends on the following two factors. First, distance of the screen from the hole. Larger the distance of the screen from the hole, the bigger is the size of the image. Second, the distance of the object from the pinhole. Larger the distance of the object from the hole, the smaller is the size of the image. If the height of the image is I, height of the object is O, the distance of image from the pinhole is V and the distance of the object from the pinhole is U, then I by Q equals to V by U. Thus, the size of the image formed in pinhole camera depends on the opposition of the object in relation to the position of the screen from the pinhole. The ratio I by O is known as the magnification. For a magnified image, the distance of the object from the pinhole U must be smaller than the distance of screen from the pinhole V. Of course, as the size of image increases, its density or brightness decreases because the same amount of light now spreads over a large area. Note, a pinhole bigger in diameter produces a blurred image. So here we have finished this lecture, this part. It is requested to all of you kindly revise the facts and figures that all we have discussed in this lecture and keep yourself ready for the next lecture. With this note, let's end this lecture and thank you.